The next area to be discussed is the projection light source. Since the majority of AAFES theaters use the carbon arc as a light source, we'll concentrate our area of study to this method of producing the high-intensity light needed for projecting a motion picture. The occupation of motion picture projectionist began when a light source was coupled to a projector. For an audience of many people, the first movies were illuminated by a flame fed by a block of calcite, similar to the modern substance known as carbide. This method had a short life and soon gave way to the carbon arc, which is now stepping aside for the xenon lamp, an arc surrounded by a special atmosphere contained inside a quartz envelope. Now the most powerful light to pass through the eye of a needle, the projector aperture. Motion picture projection would never have reached and could not maintain its present high place without the aid of the carbon arc or xenon light source. The increasingly larger screens, long projection throws, and demand for higher levels of screen illumination in both indoor and drive-in theaters, where screens may be 150 feet wide or even larger, require an intensity in the light source that only the carbon arc or xenon lamp can supply. The brightness of the positive carbon crater or xenon anode may be as much as 7 million times the brilliancy of the screen. The high-intensity carbon arc is such a commonplace and generally useful light source in projection applications that little thought is ordinarily given to the physical processes involved in the operation of such a source. Since a temperature of approximately 2,800 degrees is sufficient to produce a white heat, some of the brightness of the carbon can be attributed to particles of incandescent carbon giving off light energy in the area of the arc crater. Due to these extreme operating temperatures, the arc lamp requires the highest degree of recurring maintenance. The brightness of the high-intensity arc is the result of a combination of high concentrations of electrons in the arc stream combined with an atmosphere of flame materials volatilized from the special coring of the positive carbon. These flame materials are in most cases compounds of the cerium group of rare earth metals that are combined in a mixture with carbon in the core. As the carbon burns, forming a crater, the core is exposed to the extreme arc temperature and is vaporized into the crater enclosure. Part of the core material leaves the crater floor as a gas, while the rest is released in the form of small particles of molten core material. The rare earth atoms in the gas are bombarded by electrons to produce very intense light. It may be helpful here to picture a hailstorm in the positive crater with many billions of rare earth atoms continually colliding with each other and with electrons. As the result of such collisions, a rare earth atom absorbs energy and is transformed into an excited state generating light. All the brightest portion of the gas ball cannot be focused on the film plane unless the crater of the positive carbon aligns exactly with the optical axis of the mirror, which is in alignment with the center of the aperture. When misalignment occurs, the plane in focus will include either shell light, which is of a lower order of intensity and more yellow, or arc stream light, which is also of lower intensity and more blue. The image of the gas ball must fall precisely on the film plane if a maximum amount of light is to pass through the rest of the optical system. Finally, the optical axis of the projection lens must be exactly along the axis of the mirror and aperture, thus permitting maximum light transmission. The alignment of both the positive and negative carbons can be seen on the arc imager card. The carbon should be aligned so they sit in the indicated position during operation. If all elements are operating correctly, you'll get the best light on the screen. The carbon arc lamp consists of 7 operating components. They are 1, the arc feed motor, which feeds the carbon rods into the area of the arc as they are consumed. 2, the reflector and its associated assembly and adjustment controls. 3, the negative carbon advance assembly, which advances the negative carbon into the area of the arc and provides the negative electrical connection to the carbon rod. 4, the positive carbon advance assembly, usually referred to as the positive tray. This component provides the electrical connection to the positive carbon rod and provides the mechanics to advance the carbon into the area of the arc during operation. 5, the positive drive, which powers both the positive tray and the negative carbon advance assembly. 6, the hand dowser assembly that protects the mirror and the projector head from the intense heat rays of the arc when the projector is at rest, And 7, the power supply, which is no more than a low-power direct current arc welder. As you may have experienced, depending on your tenure as an AAFES projectionist, it's not any fun to have to hand-feed a carbon arc lamp house during the presentation of a feature. By and large, the bulk of the mechanical failures of the lamp house can be attributed to the neglect of the arc feed motor. One of the most common abuses the arc feed motor receives occurs when the well-meaning but uninformed projectionist over-oils it. Most projectionists have difficulty gauging the amount of oil required for effective lubrication, and all too often, when more than one projectionist works at a given theater, the motor is deluged with multiple over-oilings, which instead of improving its operation, is the primary cause of its premature failure. To overcome this type of failure, 2 things must be done. First, one member of the projectionist staff must be appointed to perform all routine lubrication. Hopefully, this will end the multiple over-oilings of the motor. Second, a lubrication chart showing the planned dates for oiling each component should be made by the individual responsible and posted in the projection room for use by the other projectionists when required. Once a month, the arc motor should be removed from its supporting casting and the carbon brushes and their holders inspected. With the brush cap removed, the brush tension spring will then be exposed. A gentle outward tug on the spring will tell the story. If the action of the brush in the holder is smooth, you're in good shape. If not, maintenance of the motor is in order. Servicing consists of removing the brushes and cleaning the interior of both brush holders using a cotton swab saturated with alcohol. Repeat this process until a clean swab tip is obtained. If the action of the brush in its holder is sluggish, you have the beginnings of a premature failure, and the motor will have to be disassembled for a thorough cleaning. To clean the motor, first disconnect the 3 electrical connections in the area of the fuse block. These wires are color-coded, and a diagram of their proper connecting points is usually located on the fuse block cover. After removing the brushes, unscrew the 4 bolts that are located in each of the bell housings to expose the interior of the motor. Here you can see the magnitude of the over-oiling problem. As the motor runs, the excess oil leaks from the area of the bearing down the armature shaft and is thrown throughout the interior of the motor, including the exposed ends of the carbon brushes. The oil then mixes with the carbon dust that is always present and forms a sticky sludge, which eventually jams the brush in its holder and causes it to lose electrical connection with the commutator surface. When this electrical connection is lost, the motor stops and your problems begin. The motor interior should be cleaned with a suitable solvent such as type cleaner. Avoid stressing the electrical connections to the brush holders. With the cleaning process complete, add 1 drop of projector oil to the bell house bearing. The commutator should be cleaned with a pencil eraser until a uniformed copper color is obtained throughout. Be sure to clean away any debris left by the eraser at the end of this procedure. The motor can now be reassembled. Confirm the free spin of the armature before and after the tightening of the bell housing bolts. This method will avoid binding of the armature shaft caused by incorrect alignment of either bell housing. Worn, cracked, or broken brushes should be replaced. Brush replacement should always be done in pairs. Avoid mixing old and new brushes in the same motor. When installing new brushes, confirm their complete freedom of movement in their holder. Because they're molded, some brushes may need to be lightly sanded with an emery board or fingernail file to obtain a proper fit. When reinstalling the original brush set, make sure they're returned to their original holder and position. This is necessary because of the wear pattern that develops on the face of the brush. To determine the correctness of the brush position, insert the brush into the holder and apply pressure by depressing its tension spring. Rotate the armature in a clockwise direction. If a light buzzing sound is heard, remove the brush, turn it 180 degrees, and reinsert it into the holder. If the position of the brush is correct, the motor will rotate smoothly without creating the buzzing or traveling sound. Repeat this process for both brushes. With the motor reassembled, it can now be remounted on the lamp house. Reconnect the motor wiring to the lamp house interior. If you have any doubts about the placement of the wires, check the diagram or the other lamp house. Some alignment between the shaft of the arc feed motor and the shaft of the worm gear located on the positive drive will have to be made. This alignment is usually accomplished by leaving the motor mounting screws about hand tight. With the lamp operating, gently adjust the motor position until the coupling spring ceases to vibrate. Once proper alignment has been achieved, secure the motor mounting screws. The reflector is the major optical component of the lamp house. It is mounted in a cradle that permits adjustments that become necessary from time to time. The control for the adjustment of the reflector are located on the rear door casting. The lower control adjusts the vertical axis. The upper control adjusts the horizontal axis. The center control is the override feature for the negative feed assembly. The reflector requires vigilant care if it is to maintain its optical properties. Because of the extremes of its working environment, it requires daily cleaning. Use the Bonami cleanser that has been provided. Be sure never to clean the reflector when it is hot. The negative carbon feed assembly is located behind the mirror cradle. It feeds the negative carbon into the area of the arc. This assembly should never be oiled except at the oil ports that have been provided. Adjustments for controlling the vertical and horizontal position of the negative carbon are provided to maintain a flat face on the positive carbon as it burns. The intermittent feeding action of the negative assembly is accomplished through the ratchet mechanism, which is activated by a push rod that runs the length of the lamp house and is driven off a cam located inside the positive drive. The push rod intermittently presses against the ratchet mechanism lever. The thumb screw located at the bottom of the lever provides a means for adjusting the feed rate of the negative carbon. Turning the thumb screw clockwise increases the length of travel of the ratchet arm, which in turn increases the feed rate of the carbon. Turning it counterclockwise shortens the travel of the arm and reduces the feed rate of the negative carbon. The spring-loaded carbon clamp provides the DC electrical connection for the negative carbon and is completely insulated from all other components. The positive carbon feed mechanism, usually referred to as the positive tray, provides the mechanical means for advancing the positive carbon into the area of the arc as it is consumed. Its feed rate is set by the feed rate control, which varies the speed of the arc motor. The positive clamp provides the high current electrical connection to the positive carbon. Fed by a flexible cable, the clamp is totally insulated from all other electrical connections and should never be lubricated. Because of the extremes of operating temperature, oxidation of the positive clamp cable connection is inevitable. For this reason, the quality and tightness of this connection should be checked periodically. The positive carbon rest is the primary adjustment for obtaining the correct optical alignment of the positive carbon. As in many other areas of projection equipment, proper component alignment requires special tools. However, in an emergency, should the rest be damaged during lamp operation, the following procedures will give a good relative alignment of all components. First, remove the set screw holding the damaged rest. Note the position of the 4 dowel pin alignment holes that surround it. When confronted with this task, it may be helpful to draw a small picture of what you see. Two of these holes mate with corresponding alignment pins located on the main frame casting of the positive tray and preset the vertical position of the rest. Check the edges of the replacement rest for the carbon size imprint, which should be stamped into the metal. These numbers correspond to the two positive carbon sizes used in AAFES theaters. When installing the replacement rest, the number of the carbon size used in your theater should be facing you. In cases where the replacement rest does not have an imprinted carbon size, refer to the drawing you made earlier and position the alignment holes of the new rest accordingly. To check the trueness of the rest alignment, first select a straight positive carbon. The straightness of the carbon can usually be confirmed by rolling it on a flat surface. With the positive carbon placed in position, release the positive feed lever and run the assembly through its complete cycle. If the tip of the positive carbon veers from center, further alignment of the rest will be required. For horizontal misalignment, gently tap the rest on either side until the carbon travel is in a straight line throughout the complete operating range of the mechanism. One of the most common symptoms of positive carbon misalignment is the need to continuously adjust the position of the negative holder to maintain a flat face on the positive carbon. When the carbon is out of alignment in the vertical plane, erratic burning patterns like this one develop. Note the position of the positive carbon as it nears the end of its burn. This type of problem usually requires a modification of the positive rest support casting and should be accomplished by the equipment and facilities technician responsible for service at your theater. With carbon alignment achieved, the mirror can now be adjusted as required to obtain a flat light field on the screen by using the respective mirror controls. If you cannot obtain a proper adjustment of the positive carbon or mirror by using the procedures that have been outlined, don't hesitate to call for service. The projection lens is the final step in the delivery of a sharp, clear screen image. As we shall see, it requires constant inspection and the use of proper procedure for its effective care and cleaning. The image-forming property of the lens is a familiar phenomenon. The principles which produce the projected image in the simple projection system are the same principles which operate in cameras, telescopes, binoculars, microscopes, and other optical devices. The projection of a motion picture on a screen is based on the principle of the formation of an image by a convex lens. The simplest type of projection system consists of a light source, an image on a transparent base, and the lens. To focus the projected image, the distance between the picture on the screen and the lens is varied until the sharpest image on the screen is obtained. Adjusting the distance between the picture and the lens for maximum sharpness of the projected image is called focusing, and every commonly used projection system has some convenient mechanical means for making this adjustment. The lenses required for projection come in two sets. The lenses on the left are for the projection of a standard or regular size picture. This lens set, one lens for each projector, is usually referred to as the flat lens. The lens set on the right are for the projection of a cinemascope picture. As you can see, each scope lens comes in two distinct parts. The smaller lens, usually referred to as the prime lens, and the larger lens called the scope attachment, which comes in various shapes and sizes. Each lens is numbered either 1 or 2 and corresponds to the projector in which each is to be used. The need to use a given lens in a specific projector comes from the customizing of the optical train of each machine during the initial setup of the equipment. The prime lens assembly comes in 4 distinct parts. They are: 1, the focusing ring, which ensures that the lens will always be in an in-focus condition when installed. 2, the lens adapter, which modifies the diameter of the lens. 3, the lens shown here with the adapter and shroud removed. And 4, the lens shroud, which protects the rear of the lens from accidental damage and controls the reflected light from the rear element of the lens. Each lens set has a corresponding aperture plate, which, like the lens sets, has been tailored to the projector in which it is to be used. The aperture will determine the final size and shape of the projected image. The aperture plate on the left has a rectangular opened area, and it is for the projection of a standard-sized picture. while the aperture plate on the right has a large, almost square open area and is for the projection of a cinemascope picture. This difference in open area makes for easy identification of each aperture plate type. Each aperture plate should be numbered to agree with its corresponding lens set. The inspection of the lens is a simple procedure. Just hold it up to the light and look through it. If debris is seen, the lens should be cleaned. Clean the lens only when necessary, using the moisture of your breath and the lens tissue that has been provided. Never use your shirt or any other material or liquid that may damage the soft optical coating on the lens surface. A clean porthole glass is also essential for a clean, sharp image. It should be inspected on a daily basis and cleaned as required. We're now going to demonstrate the proper procedures for threading the projector and operating the carbon arc lamp house. Although the methods you adopt may differ slightly, either because of your manual dexterity or personal preferences, the end results should be the same as those to be shown. The first step in threading the projector begins by opening all the film path assemblies. Load the film to be shown in the upper feed magazine. Don't forget to lock the spindle down. Pull the leader of the film roll down to the take-up magazine and wind it around the take-up reel in a clockwise direction. Take care not to let the film touch the floor, as the always present static electricity attracts dirt like a magnet. And once on the film, it is distributed throughout the print during projection. The damage done by this type of debris appears on the screen as very small specks and scratches and is most noticeable by the noise it produces on the soundtrack. The entire threading path of the projector is shown here. To make the threading process as easy as possible, you should first lace the film in its approximate final position within the film path. With this accomplished, final lockdown begins at the film trap by first positioning the intermittent sprocket in the rest or lock position. This condition is indicated when the line on the outer bearing support casting aligns with the line on the sprocket shaft collar. You can position the sprocket at any one of its 4 at-rest positions by turning the sound head motor knob. The film should be positioned in the trap so that the center of the numbered frame on the film aligns with the approximate center of the illuminated framing port. The frame used for framing the film in this procedure, depending on the type of leader, is either a footage or a second countdown number. The numerals 6 and 8 are the most often used settings depending on the type of leader used. The centering of the frame in front of the illuminated port is accomplished by selecting the proper set of sprocket holes that are to engage the intermittent sprocket. One of your final checks of this area will be to confirm that both sides of the film lay flat against the face of the sprocket and that the teeth are properly engaged. With the proper sprocket hole selected, a slight pull on the film in an upward direction will hold the film in place, freeing one hand to close the film trap door. To relieve the pressure on the door catch, move the door to its furthermost open position, depress the release lever, and gently close the door. The upper loop of the film should be of sufficient size to allow for the proper feeding action without touching the film brake trigger wire. Before closing the pad roller assembly, make sure the sprocket holes on either side of the film are properly engaged. The easiest procedure for sizing the loop below the film trap can be accomplished by using the film stripper as a touch point in conjunction with the width of your first finger. As before, make sure that the film is properly seated before closing the pad roller assembly. When threading past the sound drum, the tension of the film around the drum should be lax enough to permit the insertion of your first finger between the film and the bottom portion of the projector mechanism casting. To adjust the film tension around the sound drum, engage the film to its tightest position on the upper sound head sprocket assembly, and then back off 2 sprocket holes and close the pad roller. Close the sound gate by pushing the locking knob of the gate forward until it clicks in the locked position. To size the loop above the lower sound head sprocket, normally called the holdback sprocket, position the film so it can touch the lower sprocket film stripper and accommodate your first finger. After checking the film for proper seating, close the pad roller assembly. Remove any excess film by turning the take-up reel in a clockwise direction. Always cinch down the take-up spindle against the reel. This will prevent a sudden jerk on the film at startup, which could damage the print. You should also cinch the spindle of the upper magazine against the full roll of film in a counterclockwise direction. With the threading of the film accomplished, turn the machine over by hand, listening closely for any tearing or crackling sound that could indicate film path misalignment. Finish the job by closing all the compartment doors. The preparation and operation of the lamp house requires constant vigilance on the part of the projectionist if the desired end results are to be achieved. Lamp preparation begins by inserting both the positive and negative carbons into their respective holders. The positive carbon is held in position by the positive rest and clamp. The clamp assembly can be moved by engaging the release lever. It's a good practice to position the clamp assembly to the furthermost rear of the positive carbon to prevent you from running out of carbon before a given reel ends, causing either a darkened picture or no picture at all. Avoid over-tightening the clamp on the carbon. The burning end of the positive carbon should be positioned beyond the rest about 1 1/8 inches. Setting the positive carbon at this distance from the rest should get you somewhere within the optical axis of the mirror. To position the negative holder, use the center override knob for the negative feed and move the assembly to its furthermost rear position. Insert the negative carbon in the holder by raising the spring-loaded clamp. Position the tip of the negative carbon so that it protrudes beyond the front of the negative guide about 1 inch. Then release the holder. To start the lamp, first make sure that the hand dowser is closed. Turn on the lamp house power supply and momentarily touch the 2 carbons together, then quickly draw them apart to start the arc or burning action of the carbons. Positioning both carbons so that they appear on their respective lines on the arc imager card. During projection, constant monitoring of the lamp house operation is required to ensure that the carbons remain in alignment to give the best possible illumination on the screen.
Well, there you have it. The film's been inspected, the equipment's serviced and cleaned, and it's ready to go. I'm sure you've realized by now that you're not going to be able to remember everything that you've seen here today. So you may want to view this tape again after you've had more on-the-job experience. Your performance as a projectionist will determine the patron's opinion both of you and of us. It's our combined goal to deliver the best quality product possible. You're the key in reaching that goal. To help, there's a wealth of information and assistance available to you from every level of AFI's management. No matter what the question, no matter how big or small the problem, we're here to help. Asking questions can save you and us considerable time, money, and most importantly, it can ensure the patron's continued confidence in us as a team that is able to deliver the high-quality product and service that they deserve and expect from us.